Hey everybody, it's Ben with 8FD Designs in Decatur, Texas. Today we're out in the welding shop to introduce you to something we did long ago. 20 years ago, we shot a video series called Weekend Welder. The purpose of that series was to introduce DIY people to hobby welding, starting with a very limited number of tools and easy projects, and working up from there. We've come a long way since then and have a whole lot more tools, a much bigger shop, and have done a lot of very interesting projects over the years. It's interesting to note that we still have a lot of the exact same tools that we started with way back then. Just like me, they're older and more battered, but it's the same tool and they still work. So this is the first half of our original Introduction to Welding video, showing how to set up a work area and the basics of stick welding.
This will be our basic work area. We could work inside, but welding produces a lot of sparks and bits of molten metal that have a tendency to fly behind things and set them on fire. You're much better off to have an open area like this to work in. We have a nice wide area of fairly flat concrete. We also have a 220 volt plug over here that we can use to power our welder. We have a 110 volt plug for our smaller tools, and we have a fire extinguisher right here where we can get at it if we need it. If you do decide to do your welding inside, make sure your work area is well ventilated, as the fumes and gases from welding can be dangerous. Different types of electrodes have different cautions on them, so make sure you read the warning information on any electrodes before you use them. Before we start setting up our tools, let's go over some safety issues. The two main dangers in welding are burns from hot metal or from the rays of the arc. To protect against these dangers, the clothes and accessories you wear are very important. Starting at the bottom, I am wearing steel-toed safety boots tightly laced up. I have on pants without cuffs that fit down over my boots, and I'm wearing a long sleeve shirt. My welder's gloves come up high to cover the end of my shirt sleeves, and my helmet comes down low to cover my chin and neck. Two more safety items you need is a lightweight pair of cotton gloves for when you're cutting or handling materials, and some clear safety glasses for the same purpose. Now I have to admit that when I'm out here welding by myself on the weekend, you'll usually find me in a greasy pair of jeans and an old ragged sweatshirt. The important thing is that you're covered up for your protection.
Because we want to show you that welding is something that just about anybody can do, we will start off with a limited number of tools. You can get started welding without going to great expense, and the power tools that we add later on will not make your work that much better, just faster. Start out with a folding table to hold supplies and tools. Then add a pair of folding sawhorses and a small plywood top to go on them. For our welder, we have an AC/DC 200 volt arc welder that is suitable for a wide range of welding tasks. To lay out our work, we need a tape measure and a pencil, a frame square and marker. To finish out our tools, we have a vise along with two clamps to hold it in place, a hacksaw, two files, two wire brushes, a chipping hammer, a hammer, and a 1-inch belt sander. For supplies, we have some standard electrodes, some emery cloth, and a handful of nails. This is all we will need to get started. Before we go any further, let's define what we are talking about.
In arc welding, an electric current is used to generate heat to melt metal and form a weld. An electric arc is struck and held between the workpiece and the tip of the electrode, producing a point of heat in the range of 8,000 degrees Fahrenheit. The arc is used to melt a small portion of the two pieces being joined, with extra metal being added from the electrode. When the molten metal cools and solidifies, the two pieces are fused together. Let's look at our welder in a little bit more detail. As I said before, this model will weld both in AC and DC mode and has variable amperage setting. You can do anything from very light hobby welding to fairly heavy maintenance welding with this unit, so it may be more than you need if all you're going to do is light work around the house. We'll look at some other welder models in a later episode, but they basically all work the same. As you can see, we have this unit mounted on a four-wheel cart, which makes it easy to move around. Once we've picked up a few more welding skills, we'll make a cart that'll hold both the welder and some of our supplies and equipment. Once you select a welder, make sure that you read the instruction manual to find out exactly how your particular model works. All of our tools store in a fairly compact area and don't take long at all to set up. In arc welding, the electrical circuit that forms the arc is completed when the electrode, mounted in the electrode holder, comes in contact with a piece of metal that is in contact with the work clamp. In many commercial welding shops, you will find metal tables with the work clamp attached to the table rather than to the work. This is good for production work, but causes some safety problems that we want to avoid. So we'll be using this wooden table, which makes it much more difficult to inadvertently strike an arc. A key part of the arc welding circuit is the electrode. There are a wide variety of electrodes available, and they vary in size as well as in the makeup of the rod itself and the outside coating. These two electrodes are the same size, but as you can see, the difference in their coatings is quite extreme. These three electrodes are the same type, but different sizes. The smaller electrode is used for delicate work, where a lower power setting helps prevent melting the workpiece. The proper amperage setting for this electrode is 45 amps. The larger electrode is used for thicker metal, where a larger and stronger weld is needed. The proper amperage setting for this electrode is 115 amps. In all of our demonstrations, we will be using a 3/32 6013 electrode with the welder set on DC positive and 85 amps. Teaching welding visually is difficult to do for two reasons. First of all, with the helmet on for safety, a lot of the welding work has to be done by touch and feel, which is something that you simply have to get used to with practice. Second, the arc is very bright, and it's difficult for a second person to see what's happening or for the camera to properly capture it. We're going to tell you the things that you need to know and show you a little bit about how it's done, but realistically what it takes is a little bit of practice. The first skill you need to learn is how to strike an arc. Because you'll be doing this with your visor down, before we try it, you need to work on picking up the electrode holder and touching it to the piece of work without being able to see. Once we've practiced that a little bit, we'll move on to actually turning on the machine and striking an arc. To strike the arc, we'll start with the electrode on the metal like this, and then we'll move it across the metal, increasing the angle as we go along. The arc is actually formed by holding the electrode very slightly above the metal, letting the electricity jump across the space in between. A lot of instructors recommend a two-handed grip. I typically use a one-handed grip, but I keep my elbow tight against my body to brace it off. Let's give it a try. It may take you a little while to where you can easily strike that arc and hold it in place. But once you do, it's fairly easy to tell whether you've got it right or not. When the electrode is down close to the piece of metal, it has a nice firm crackling sound. As you move the electrode away, you get a much more breezy, indistinct sound. Once you get to where you can hold an even arc, it's time to start laying down a bead right on top of the metal. Since you're burning the electrode away, as it's consumed, you have to keep moving it downwards to keep the arc intact. It takes some practice to keep it in a straight line, but it really doesn't take all that long. The secret to getting a nice, straight, even weld is to watch the molten metal behind the electrode. About 3/8 of an inch behind the electrode is where the molten metal should start to solidify. If you're closer than that, you're moving too slow. If you're further away than that, you're moving too fast. I'm going to practice a few more beads, working on getting them straight and even. Then we're going to take a break, and when we come back, we'll do our first real weld. Now that you know how to run a bead, we're going to weld these two plates together. We'll start off by using this wire brush to clean off the surface. The welder works better on clean metal. What we want to do to weld these two pieces together is we'll start by striking our arc on this side where the work clamp is. If you touch this metal, since we've got a slight gap in between, you won't form an arc. Once you have an arc, what we want to do is move back and forth slightly between the two pieces of metal so that we're melting both of these two edges and putting the extra metal from the electrode down the middle. The first thing I'm going to do is show you how to do it wrong and then show you why it doesn't work. We'll pull the electrode along pointing this way so that it only melts this piece of metal and not really this one. The weld will hold for a minute, but when we put some pressure on it, it'll break. Let's take a look and see what that does. This weld is fairly spotty and has some gaps along it. When we take it loose, it'll break fairly easily. Now let's go back and do it right. This gives us a much better looking, stronger weld that would be very difficult to break.
I hope you enjoyed this video and learned something from it. If you want to continue to follow along, subscribe to our channel, and here are a couple more welding videos for you to look at. 8FD Designs works out of 32,000 square feet of building on 3.5 acres in Decatur, Texas. If you're ever in the area and you're interested in our markets, our store, our classroom, or our various shops, come and see us in Decatur, Texas.